Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let's again move to the next module of part number 5. So 5.03. This is about girder bridge superstructures. So let us talk about that. So we already know what do we mean by superstructure, okay? And what do we mean by girder. So let's start. Again, before I forget, I would like to give thanks and courtesy to the association that made this presentation. Okay. So they are the American Institute of Steel Construction and the National Steel Bridge Alliance. Okay. So let's make a description and explanation of these slides. So barriers. So there are several types of barriers. So barriers is a part of the bridge or the highway wherein we want to protect something. We want to protect generally the vehicle to fall off the bridge. Okay. So it is the what? The minimum. There is a minimum standard, the height. So actually, we can do it very high, but there is a minimum requirement. So this height is the minimum standard. Anyway, this is a minimum. There is no maximum. So you can put up barrier that is as high as you can. There is no maximum. So anyway, we have this minimum in order to help alleviate the falling off of vehicle out of the bridge. Okay. So concrete, temporary concrete barrier or movable or portable are those type of barriers that have what? I think they are 1 meter. The length is 1 meter. So you cannot see any cut bit per 1 meter. This is continuous. So this is not portable. This is not temporary. This is a fixed. This is a fixed type of barrier. Okay. So this cannot be moved. Okay. Compared to the portable or temporary concrete barrier. So this is fixed. So this is again barrier which is steel barrier. Steel barrier with what? Column. These are column post. These are column, steel column, steel columns, and what? Rails, no? Barrier rails. Okay. So I would like to go to the next picture. So those are the pictures in your front and in your right side. On the top picture, it looks like a highway. Okay? The only indication that this is a bridge is the barrier, the type of the barrier. Okay? The highway barrier is a little bit shorter. Okay? And the bridge barrier is a little bit higher and more expensive. No? So there are several series of what? Columns, okay, and rails, okay. Unlike if this is just a highway, there are sections that have railings on the side of the road to protect for something dangerous. Although maybe those sections are not bridge, okay. So however, you can differentiate if you see the protection barriers for bridge are a little bit higher. Decks. It provides lateral stiffness to the superstructure. So decks. Okay. So this is what? This is the parapet. This is the parapet. This is another parapet. So the edge barrier could be what? Could be a what? A parapet. So that is a parapet. Okay. So could be a parapet. So the edge barrier for bridge. Okay. So this part is the bridge sidewalk. This part is the sidewalk. This part is the sidewalk. That also functions as what? Emergency stop if inside the bridge something happened, emergency. Okay, so that could be. But in any bridge, it is what? It is not okay to stop or park at any portion of the bridge. That is the general rule. But in times of emergency, so emergency, you can use this portion. Okay. And only in times of emergency, meaning the question of life and death. Okay, there's a question of life and death, so that is an emergency. So you can use that sidewalk. So this is actually the pavement for cars and vehicles. Okay. This is what. So the decking is here. So this is the decking here. The decking is underneath here. Okay. So sometimes the decking could connect only this part. Could connect this part to the next girder. But if that is the decking, after the superstructure is cured, you can take off the temporary deck. Okay. Future wearing surfaces. So this is what we call the wearing surface. Okay. So wearing surface is where it is the part of the bridge wherein it is direct contact with the wheels or the tires. Okay. The black portion is asphalt. Okay. Okay, that is asphalt, and they put somewhat the mixture of good quality and established. So asphalt is good for us for surface, for wearing surface, as a wearing surface, because it is the most economical material, number one, and number two, it could easily be replaced. Okay. Number three, it is not smooth. Okay. Even though it may look like smooth, it would give you the proper and the good amount of friction so that there is no car sliding above it. Okay. So car sliding is avoided using this. So that is actually the purpose of wearing surface. Wearing surface must be wear after some time. So if the design is 3 years, the wearing surface must be replaced every 3 years. The design is 3 years. If the design is 5 years, so it must be replaced after 5 years. Okay. Wearing meaning it is already damaged, it's already gone. The surface is already gone. Okay. A little by little, daily grinding, daily use of the bridge of the surface, it will be gone after some time. Okay. Okay. Little by little every day. Okay. So that is what we mean by wearing surface. Okay. Smooth riding but prevent slide. Okay. deck forms. So this is the deck. The underneath portion is deck. Okay, deck, or it may also involve the what? The deck may also involve some thickness of the pavement. So deck is a layer. Deck is a layer of pavement. So it depends. Even the deck forms could form parts of a deck if the forms are not taken off after curing. So that is now permanent. So deck and deck forms. Okay. Provides formwork for cast in place deck. Can be stay in place or removable. So it depends. It can be removed or can be forever, can be fixed. Okay. So this is what we call the deck forms. Okay. So this white portion, these are the deck forms. The white, this one. Okay. The silver colored portion, these are the deck. So the silver portion, the silver colored portion, these are the deck. Deck forms. Okay. I-Girders. Okay. So letter I, so we mean WC. Okay. We mean I-Girders. That means W beam. Okay, W type. We mean W. This is what we call W. Okay. So this is the table out of the code. Okay. We will only use table from the code or from the textbook. Okay. Okay. So that is our what. So efficient for shorter spans, limited size and shapes. So using I-Girders. Rolled beams. Okay. So meaning hot roll. You cannot cold roll the I-beams or the W-shape beam. You cannot cold roll. After hot rolling, you can cold roll. But directly cold roll, you cannot do it. That's too much. Okay. So it's too deep. It's too deep for rolling purposes. So hot roll, so rolled beams. These are the types of girders. Okay, girder plates. Girder plate. So this is not a girder plate. This is a girder rolled beam. That is the difference of girder plate from the girder beam. This is girder plate or plate girders. Okay. Okay, there are what? These are the brace, okay, or the plates. The plates is actually a brace. Brace meaning it supports, it adds strength. That is what we mean by bracing. We want to add strength to the girder. Okay, deep girders can span very long distances, vast range of sizes and shape. Okay. Box girders. This is an example of box girder. Box girder, there are several types of shape. This is a trapezoidal box girder. There are rectangular, there are square box girder. Rectangular box girder. I already see rectangular, square, and trapezoidal, but I have yet to see a triangular. I don't think there is a triangular box girder. So this is what we call box girder. The whole, this whole assembly is what we call box girder. Okay. So cross frames. Well, this is the component of cross frames. There are joints, which in this case we use what? Steel plate for the joints. Then put up a cross element. Okay, so these are the cross elements. Usually cross elements are made up of angular bars, angles. Okay, so here this is not angular but T. Okay, T-section. Okay, they use T-section for the what? For the cross frames. Okay, T. So T. So letter T. Okay. So it could be angular, could be T. It could also be what? C. Channel. Okay. Diaphragms. So this is what we mean by diaphragm. So, similar to cross frames, provide torsional stiffness. So that is the real function, to provide torsional stiffness. So it improves buckling resistance. So it improves buckling resistance because of what? Provision for torsional stiffness during construction and in the final condition. Not only during the construction. Typically used on shallow beams. So diaphragms, okay? Similar to cross frames. So these are the diaphragms, okay? So these are the diaphragms. So those, the diaphragms, okay? Oh, this is what? W frame, okay? W beam. This is W beam. Okay, connected by bolt, okay? Connected by bolt to the what? W frame, W beam. So lateral bracing. So lateral bracing using trusses-like elements. Oh, this one. So these are the lateral bracing using trusses-like elements. Okay, and connected by using bolts or what rivets. Okay, used to provide lateral stiffness and limit lateral deflection. So again, this is against what local and global buckling. Okay. So what type of bridge is that? This one. Okay. So true truss, no? This is a true truss bridge. We have a true truss bridge. Okay. This one. So this is what we call bearing. So this is a bearing. This is a bearing. Okay. Sometimes it also looks like circle, but this is not circle, but cylindrical. So like this one, this is what circular what sector of a circle. This is a sector of a circle, and this is the peaks. This is the peaks component. This is the circular one. Okay, this moves a little bit. So this move. That's why bridge actually moves. The bridges are not fixed. Actually, the bridges are not fixed. This is the most common type of bearing, the block. This one, okay? It's the most common type of bearing. Okay? This is what? A type of bearing that is earthquake resistant type of bearing. Is also what? This is what we call a bearing which is what? Pin. Roller and pin connection. Okay? Roller and pin connection. This is another type of bearing which is what? Earthquake resistant type of bearing. Okay? That is what we mean by bearing. Okay? Understood? Like this. Okay? Sector of a circle, but this is what? Cylindrical like shape. Okay? Like this. Okay? So we have a dowel inside, but the dowel is smaller than the hole. There is a hole in dowel, so it can move. It can play. There's a play, but it is not fixed. Okay? The bridge is not fixed, but good luck carrying the bridge. So actually, a bridge can be carried from one place to another because it is not fixed. Okay? It is not placed it is just placed over the bearing. So you can what? Take off the bridge and place it to another new location. Okay, so you can do that, but it is so heavy. You need what? Very rigid structure or what crane that could what carry it. So it's almost impossible to transfer it to another site. Okay, so what are the components? So masonry plate. Okay, so masonry plate. So actually here, this is not a masonry plate. So this is a steel plate. Okay, this is a steel plate in here. So this one is masonry plate. Okay, masonry meaning we have what? We have cement, sand, and water. Dowel. The dowel is what? Looks like a key. Looks like a key, so that it could what? Could prevent sliding. Could prevent sliding. No? So that is the purpose of dowel. But the dowel itself is smaller, so it could allow a little bit of play, a little bit of motion. Okay? It allows. So it is called wing plate because it is flapping side to side. Okay. So sole plate. So this is the part that is sole plate. So there is what? Hollow portion here. There is a hollow portion inside this. The hollow portion looks like this. And there is what? A mechanism that could add another play. So there is a what? They are not connected. So it could play side to side. Okay. So rocker. This is what we call the rocker type of bearing. Rocker bearing. So elastomeric bearing. So this is what we mean by elastomeric bearing. So meaning this is not concrete. This is not steel. So this is plastic, a very hard type of plastic. That is what we mean by elastomeric. Okay. So the material is elastomeric, very hard type of plastic material. Rubber and plastic, what? Actually, in engineering, rubber is a type of plastic, type of elastomer. So the type of elastomers are the different types of plastic and the different types of rubber. So it could be what? Mixed so that it could create what? A desired property. So this is bearing. So imagine if the elastomeric bearing wears out, so it will what? It will be used up to, for example, 30 years or 50 years. So you need to what? To have a jack. To have a jack it up so that you can replace the bearing underneath. Okay? That is the what? The solution, engineer. So do you know what is jack? Okay, jack is similar to what? Car or vehicle jack. If you have a flat tire, you need the jack. Okay, for flat tire, so you can what? Carry the weight of the load by using the device called jack. So it carry the load. So take off the bearing, then replace with new type of bearing. So this is what we call bearing. Okay. So thickness of cover, layer of elastomeric. So beam section at bearing. So we have what? So different layers here, no? With steel lamination, no? So this type of bearing, elastomeric bearing has what? Steel lamination. So steel reinforcement. So this is the steel reinforcement. The black lines are steel lamination steel plates. Okay, reinforcing the plastic material. Okay, so total thickness, then width. So still reinforced elastomeric bearing. Pot bearings, guys. What is the remember pot bearings like this? No. Okay, pot bearing. Stainless steel slide plate with PTFE. PTFE is plastic, a very hard type of plastic. Okay, allows for high loads, large movement, and moderate rotation. Beveled sole plate. Okay, so this one is the beveled sole plate. Okay, so guide bar. So this is the guide bar. Okay, this is the guide bar. This and this one. So stainless steel slide plate with PTFE. This dark portion. This dark portion is the stainless steel slide plate. Okay, this dark portion, this one, this one. Don't worry about the arrows; they are wrong. Okay, so the black portion here are the stainless steel slide plate with PTFE. Which one is the piston? This is the piston. This is the piston. Then we have elastomeric pad. This is the elastomeric pad. This is correct. Correct arrow, elastomeric pad. Piston. Base plate, which is the base plate? This is the base plate. So, base plate bolted to the what? Pier cup. So, bolted to the pier cup or pier itself. Okay. That is the base plate. Then put the elastomeric pad, then put on the piston. So put on the guides. These are the guides. Guides. The black portion here are the PTFE and stainless steel slide. Okay. So sealing rings. Sealing rings. Okay. Base plate, sealing rings. This one. The horizontal one, sealing rings. Sealing rings. Okay. Guide bars. Okay. So another guide bar. This is a guide bars. Beveled sole plate. So beveled sole plate. This is a plate. Okay. So this type of bearing. So there are several types of bearing. Disc, pot, elastomeric, cracker. These are the type of bearings. Cracker, elastomeric, pot, and this type. This type of bearing. Urethane is the material. So meaning that is plastic. Plastic material, urethane. So take note, these plastic materials are so strong. Okay? But they are so expensive. That's why we cannot use this as the main material. These plastic are so strong. They are comparable to concrete. Okay? But they are so expensive. That's why only for bearing purposes. No? Okay? So, fillet welds. Fillet welds. So, these are just fillet welds. So, limiting rings. So, these are the guide. On the previous slide, this is called guide. But now, they are not guiding anything. That's why it is called limiting rings instead. So, top bridge plate. So, top bridge plate. Masonry plate. So, this is the masonry plate. So, this is masonry plate. This symbol is steel. So, this masonry plate is actually steel. Okay? This is the symbol for steel. This double diagonal lines. That is the symbol. Meaning they are steel parts. Okay? That's why this is called sole plate. So, this is steel component. Sole plate is masonry plate. So, sole plate, masonry plate. So, we have what? This bearing or the pot bearing in between. Okay. So, shear pin. So, we have a shear pin here threaded into top bridge plate. So, this is the top bridge plate. just underneath the sole plate. So threaded. Okay, so there is a thread, and then we have a pin. This is what we call pin shear. Okay. So then there is a combination of disc and path bearing. So this is a disc bearing, this is the path bearing, or they can be combined. Okay, so disc bearing, okay. So there is a plastic component. So this is what urethane. Okay, component. Path bearing, also we have what? Different types of material. Okay, so path bearing. Okay. Disc bearing, guided bearing. Okay. So path bearing can also be guided. So this is non-guided type of path. Disc bearing. Path bearing and disc bearing can use guide bars or guide rings or guide components. Okay, non-guided. So guided. So the guide is there. This is the guide. This and this, these are the guide. Okay. So there is no guides. Non-guide. Non-guided bearing. So roller bearings. So they are what? Cylindrical. It accommodates heavy loads, large movements, and minimal rotation. So minimal rotation. So we have roller type of bearings. Okay, roller. There are guides on the edges. Okay, so guides. Okay. Again, that's all for this particular video. I hope you are familiar now with the different terminologies used in bridge engineering. We have talked about so many things: superstructures, substructure, their types, nomenclatures, and including the bearings and foundations. Again, this is Dr. EYPEI, Preaching Engineering for Nation Building.